100 calories of steak. It's part of why protein is awesome, because not only is it satiating and a bunch of other stuff with muscle protein synthesis and things that we'll get into in a little bit, but it's metabolically expensive to use protein for energy, and taking advantage of that is very, very helpful, because if you have 100 calories of carbohydrates versus 100 calories of protein, your body is spending more energy to process that protein. So that's most of what I wanted to talk about with this. So now on to probably the most depressing slide on here. 95% of diets end up not being, they don't work. Well said. They fail, and that is now, depending on the study you read and the guidelines for what they decide is failure and the amount of follow-up that they do, most of the more well-respected ones will not just follow things for a year, but more like 3 to 5 years. But when you look at the parameters, it's in the most optimistic, most encouraging studies, 80% of diets fail. And so maybe an average of 90%. But if you're looking at metrics of does this weight that you lose stay off and stay at the same level, especially once you get to losing more than 10% of your starting body weight, about 5% of the time someone will lose the weight and it will stay off. The other 95% of the time it will not stay off, and sometimes come back almost like you've angered it, and it comes back and it's even more, and we'll go over that in a little bit here. The Biggest Loser, that show where, which has a funny name. I just now realized it's a mean name. But I never put that together until I just said. But anyway, maybe they were going for that actually. The Biggest Loser. There's a reason they never have a reunion show, and it is because at last I checked, which was 6 months ago, 100% of people regained some, and in most cases all of the weight, and in some cases more than the weight that they started at, which is sad but predictable just based on how they lost that weight. And so your body is actively trying to fight against rapid and extreme weight loss. It is built in there because we are walking around with Paleolithic bodies in a modern age. And so all of our survival systems are built for any calories that I have coming in, I want to maintain them, and any fat I have on myself, I want to hold on to that if I possibly can. And so if there's something that's going on that's making me lose that fat, I need to do whatever I can. This is your body talking now. I need to do whatever I can to make it easier to hold on to fat or to regain that fat at my next meal. And so we are fighting against these defense mechanisms that were awesome if you were in 50,000 years ago, South Dakota. I don't know why you had to be in a specific place. But if it was 50,000 years ago, that's fantastic because you just found some tubers and you ate them, and you've got to figure out how to make that energy last until the next time that you can find food. It is not awesome now when it's like 3 button presses maybe on your phone to have the whatever amount of food you want delivered directly to your door, so that you can eat it and continue on watching Better Call Saul. So that's this next, I think. Yeah. So here's why it's an uphill fight. I'm kind of glad it only showed up as PDF on here because I couldn't figure out how to make them animate and show up in the right order, so they were just showing up really randomly. I was kind of stressed about it, but this makes it easier because you can read them all at once. Don't read ahead though, it'll spoil everything. So here's why it's an uphill fight. Your body, I'm going to take one quick sip of water here. Oh, I've been talking a while. Okay. Maybe, when should we do a break? In like 10 minutes? An hour? Okay. Let's do 10 more minutes and then, or just tell me when. I'm having a really good time. So here's why it's an uphill fight. Homeostasis is one of the most magnificent, miraculous features to any living system, and like a lot of stuff that we get blessed with as humans, that we have the most complex system in a lot of categories. One of those being our nervous system, and so our systems for homeostasis are exquisite, and we have really smart scientists who still are unraveling like how this all works, because it's that whole mystery of the brain is too complicated to understand itself, which is true, and a lot of our biochemistry still is. We understand a lot of it, but homeostasis is the built-in system to keep things the same. And so if it's your home thermostat, then that's simple. If it's too hot, then the AC kicks on, and then once it is cool enough, the AC turns off. Homeostasis has been maintained. And homeostasis works in a lot of our different body systems, all of them to some degree. And some of them are really obvious. Your body is exquisitely sensitive to how much carbon dioxide is in your bloodstream. Interestingly enough, it's much more sensitive to that than how much oxygen is in your bloodstream. When you have to breathe because you've been holding your breath for too long, it's the carbon dioxide building up in your blood that's pushing that respiratory drive, not the decrease in oxygen, which is part of why if somebody hyperventilates, I don't know why I'm going into so much detail about this, but it's neat. It's part of why if somebody hyperventilates before they hold their breath, it's not that they've partially increased their O2 sat some, but it's that they've breathed off all of this extra carbon dioxide that they'd normally be carrying. So they're starting with less, and it takes longer for that carbon dioxide to build up. And so that's why people will do a lot of hyperventilating to get rid of as much of that as they can. So for your respiratory system, there's really quick, immediate feedback that maintains homeostasis for oxygen and carbon dioxide levels. For hydration, it's really, really sensitive. That myth of you have to drink 8 glasses of water a day, no one really knows exactly where that started. There's like a couple different articles that had that around the same time, 30 or 40 years ago, but it's not. There's no science behind it at all. It is, and it's certainly helpful to drink a lot of water, and there's except for extreme crazy cases, there's no such thing as drinking too much of it. But your body has, these sensitive systems, these osmoreceptors that can detect how much salt is in your blood, and ADH, antidiuretic hormone, which is what keeps you from peeing. It's as those levels rise, then people get more thirsty because they're realizing that all of that stuff. It's been tested in scientific settings. You get thirsty long before you get to a level where dehydration would start to impact you. The only time that's not true, by the way, is in again cases like CrossFit. Getting hydrated beforehand and having a little bit of extra salt on board is helpful because you're losing so much water through your sweat, and it takes a little bit of time to catch up to that. But anyway, all of that to say, your body has all these systems built in to maintain homeostasis. And so with your, hold on, what was I going to say about that? So with your food intake, that system is still super good at what it does. With anything that comes to the survival of the organism, the system to maintain homeostasis is built in a way that you cannot ignore it as much as you try. It is like you can try to hold your breath as long as you want. Your body's going to make you breathe. You can try to hold your hand on a furnace or stovetop as long as you want. Your body's going to make you take it off. Anything that threatens the survival of the system it will have an inignorable alarm bell that you have to pay attention to. The way I like to think about this or say it is that a biological warning system, a survival mechanism, these are imperatives. They are not suggestions. You cannot ignore them. And the reason that that's important to know with food is for 2 reasons. One, it's equally imperative as the breathing one or as the drinking water when you're thirsty one. But it happens over these much longer time scales. The nutrient sensing and what your body does to regulate that, both with hunger and energy expenditure, these things are happening over weeks, but more accurately over months rather than over the minutes. And so it's very, very obvious that you have a biological imperative that you have to breathe because you don't have enough oxygen. It is much less obvious that you have a biological imperative that you have to eat because you don't have enough nutrient on board. You don't have enough caloric energy to use to keep the system running. That's the first reason it's important. And the second reason it's important is because systems can be hijacked. So these got it. Systems can be hijacked. So in this case, the system for regulating how much food is coming in versus how much energy you are putting out, it is built for a time when our bodies were being built, and if you're a strict creationist, then it was built in this way 10,000 years ago. And if you're a scientist, or no, if you're not, then it was getting some of the early touches 6 million years ago, and humans that were indistinct from, like, where if you just took a human and brought him forward, like you took a baby from some cave person and raised it in modern day America, at what point in our history would you have to go to until that person looks exactly the same and you'd have no idea that you were bringing them from the past? There's some wiggle room on it, but it's somewhere between 100 and 200,000 years ago when where our DNA is really almost no changes in that amount of time. And so all of the biological imperatives built around food consumption and energy expenditure were built during that time, which does matter. It's part of why paleo eating and carnivore and keto, those things, it's part of the attraction of them, and part of why there's a lot of science behind those that's really compelling, because there is truth to that. Like you are carrying DNA, the DNA that is deciding how you live, how you act, all the stuff that's really kind of outside of your direct conscious control is all DNA that's caveman DNA. And so what that means with food is that access that we have to food, both in the type of food that we have, the amount of food that we have, and the timing of when we can eat those foods, is wildly different than it was in South Dakota 100,000 years ago. And so what that's done is it's hijacked the system, and so we have this biological imperative of when we need to eat, when we are running out of energy, and what's going to happen to our metabolism because of that, that is as imperative and loud and inignorable as any other system where your body makes you do something, but it's firing for all the wrong reasons because it's getting all these weird signals that it never got when it was being built. And so this idea of and how would that guy need to eat that? He weighs 600 pounds. Why does he have to eat so much food? He is as starving as somebody who was actually starving back then, and the system's just been totally hijacked. He has no access to all the fat stores that he's carrying on his body. There's that was a lot about homeostasis. So, and that has to do with this body weight set point. That's one of the things that's built into us. Is forever it was to help us restore back to this body weight set point. When you're in pastures of plenty, you want to take advantage of that opportunity to get your fat stores back in check, get your glycogen restored, get everything back to where it was, so that when winter comes and you're fighting a squirrel to take their walnuts because you're starving, you've got as much energy going into that as you possibly can. And that's what body weight set point does. It wasn't that long ago. I mean, it was in the last, I think, 20 years that leptin really came to the forefront and got discovered. It's a molecule that our body makes that has a lot to do with our body weight set point. If you have high amounts of leptin, then your body is satiated, things are going okay, and you're burning your fat stores. And if your leptin is low, then or if you're insensitive to the leptin, which is what happens more commonly now, then your body's trying to store energy. You are more hungry, and it's not like it's in my head I'm more hungry. Well, it is, but it's like the same way that it's in my head that I'm seeing people. Like, yeah, that's where it's getting processed, but it is a real thing. It's actual hunger, the same that would be there if you were absolutely starving. And so your body is built to have this set point to maintain that, because homeostasis matters if it's water or oxygen or food, and that's the one that's getting kind of hijacked. So that leads to this next point, which is it is after you lose weight. It is, and this is not like an opinion thing, this is like scientifically documented, it is harder to lose weight and easier to regain weight. Now this study that is like where these numbers I'm referencing here, it was done on mice, just to be clear. But it's similar to what happens with humans. The numbers are less neat and they're kind of more all over the place with humans, so it's fun to just look at the murine studies and say, look at what happened to the mice. But they're mammals too, and they did this study where after they dieted them down and made them lose weight, and then they went back to their previous weight. The second time they dieted down, it was slower in losing the weight. It required more of a calorie deficit to lose the weight, but more importantly, literally twice as fast bringing the weight back. So if it took 500, well, it'd be a lot for a mouse, wouldn't it? 500 calories, living large. But if it was, I don't, what am I, they don't eat cheese, do they? Is it really? Maybe. If it was, an extra piece of cheese a day to get to their previous weight the first time, only half a piece of cheese a day would get them to that previous weight the second time. And then they did it again and again. They dieted them down, saw how long it took. And once you got into third, fourth, and over diet, you got to the point where you were losing weight. It took twice as much of a deficit or twice as long to get down to the previous weight that you were getting to. And you would regain it literally 3 times faster. So if it was a 1 piece of cheese a day to get there before, now it's just a third of a piece of cheese a day to get back to that same weight. It's the reason there are no reunion shows on The Biggest Loser, because somebody that was maintaining their weight at 2,200 calories a day, now that same poor soul has to be at 1,100 calories a day if they're going to stay at that weight. And they've actually done, I think I can talk about that now. Well, I'll just talk about it now. If you do the math on just because it kind of makes sense that a 400-pound body would have a higher basal metabolic rate than a 200-pound body because there's just more living tissue there to support. But if you do the math on people that have lost tons of weight, or on these mice that lost a lot of weight, the amount that their basal metabolic rate and that their overall energy expenditure decreases is far greater than what you would calculate purely based off of the amount of pounds that they lost. In other words, it's not just, yes, you have half of the body size and so it's decreased by this set amount because there's a ratio there and this is what the BMR is for a person at this body weight. It's if somebody starts off at 200, the energy expenditure that they have to maintain their weight at 200 is significantly higher. They burn significantly more calories than somebody who started at 300 and then makes it down to 200. Does that make sense? Okay. And that's because there's all of these defense mechanisms your body has because it wants to maintain homeostasis. And that's what when we talk about calories in, calories out, and why it's really similar to saying being poor is because you don't have enough money. Calories is true. If you bring in more energy than you expend, you will gain weight. But that truth, it becomes a distinction that makes no difference in the real world when you've got somebody who is 200 pounds and the only way that they won't regain weight because they started at 400 is by maintaining a diet that is insane because they went from, they were always eating 2,800 calories, and now to stay at this weight they have to eat 1,000 calories a day, or ride an exercise bike for 6 hours a day. The defense mechanisms that are built in will try to maintain homeostasis no matter what. And then I think this is probably a good time for a break if you want, or we can move ahead.
Yeah, let's take a break.
Okay.